Okay, I want you to imagine a world. From way out in space, it looks like a perfect blue marble, a near twin to our own Earth. But as you get closer, you realize that beautiful, serene blue is just a mask for one of the most terrifying places we've ever found in the entire universe. Today, we're taking a trip to the absolutely lethal exoplanet HD 189733b. I mean, listen to that. This isn't just some other planet with weird weather. This is a place where the fundamental laws of nature seem twisted into a form of cosmic horror. A place where the sky itself is trying to kill you. And that's the big question, right? How can something that looks so inviting be so deadly? That is the paradox we are going to unravel today. We're going to dive into the science behind both the beauty and the brutality to really understand what makes this alien world tick. All right, so this place, HD 189733b, is an exoplanet that's about 64.5 light years away from us. Through our telescopes, it has this deep, rich, cobalt blue color that really does look a lot like Earth's oceans. But, and this is a big but, this is no paradise. It's a gas giant, and it's hiding a seriously violent secret in its atmosphere. So, to really get a grip on the horror show we're about to witness, we first need to understand what kind of planet we're even dealing with. This isn't a rocky world like Earth or Mars. It belongs to a class of planets known for being, let's just say, a little extreme. So here's the deal. Imagine taking a planet like Jupiter from our own solar system, a huge ball of gas, and then just shoving it incredibly close to its star. The result is what we call a hot Jupiter. It's a world that's just constantly getting blasted by intense heat and radiation. And that insane proximity to its star, well, that's the engine that drives all the chaos we're about to see. Look at these numbers. The sheer scale of the difference here is just staggering. A year on this planet is just 2.2 Earth days. That's how fast it whips around its star. And it orbits at a distance of only 4.6 million kilometers. For some perspective, Mercury, our innermost planet, is more than 10 times farther from the sun. Being that close has some pretty dramatic consequences, especially for its temperature. Yeah, you're seeing that right. We're talking 1,200 degrees Celsius, or about 2,200 degrees Fahrenheit. The day side of this planet is a raging inferno. It is so hot that metals we know, like lead, tin, even zinc, wouldn't just melt. They would boil away into vapor. And crucially, this insane temperature is the key to understanding the planet's most infamous and terrifying feature. And this all comes back to that idea of its deceptive beauty. You know, when we see the color blue, we think of good things, right? Water, clear skies, home. But on HD 189733b, that brilliant blue color comes from something way more sinister. So, Earth's blue color? That comes from sunlight scattering off the molecules in our life-giving atmosphere and reflecting off our oceans. It's the color of life. This planet's blue, on the other hand, comes from light scattering off microscopic particles of silicate, which is the main ingredient of glass, just floating around in its upper atmosphere. So the very thing that makes the planet look so inviting is actually a giant warning sign of its deadly nature. That beautiful blue haze isn't a gentle sky. It's a vast, swirling cloud made of superheated, microscopic bits of glass. Okay, so let's put the pieces together. We have the unbelievable heat, and we have the floating glass particles. So what happens when you combine those two ingredients under the extreme physics of a hot Jupiter? Well, you get a weather system straight out of a nightmare. The winds on this planet are they're almost incomprehensible. We're talking 5,400 miles per hour. That's about 8,700 kilometers per hour. To put that in perspective, that is Mach 7 times the speed of sound. These are hypersonic winds driven by the massive temperature difference between that scorching hot day side and the slightly cooler night side. So here's how it works. First, that intense heat vaporizes silicate minerals, rock basically, in the atmosphere. Then, as this vapor rises to slightly cooler altitudes, it condenses into tiny droplets of molten glass. But here's the terrifying part. Before they can even think about falling down, they get caught by those hypersonic winds and are blasted sideways across the entire planet, creating this perpetual global storm of superheated flying glass. And that analogy is just perfect. This isn't rain like we know it. It's not falling, it's flying. It's a horizontal blizzard of razor-sharp projectiles, each one moving 7 times the speed of sound.
Anything caught in that storm would be instantly shredded to pieces.
It is so extreme, so unbelievably hostile, that even NASA, which is usually pretty reserved with its language, has officially given it this terrifying title. It's part of their galaxy of horrors. This isn't just science fiction. It's an officially recognized celestial horror story. So you might be wondering, why do we even study a place like this? A place we can obviously never visit, a place that's so completely inhospitable. Well, the crucial point is what a world this extreme teaches us about the universe, and maybe more importantly, about our own place in it. Our understanding of this planet has been a real journey. We first discovered it back in 2005. Then in 2013, the Hubble telescope confirmed that its deep blue color was real. And just recently, the James Webb telescope has given us an even deeper look into its chemical makeup, finding things like hydrogen sulfide. Yep, the same molecule that gives rotten eggs their lovely smell. Every new observation helps us refine our models of how these extreme worlds actually work. So studying a place like HD 189733b really pushes the boundaries of science. It helps us understand how planets form and move around in other solar systems. It tests our theories about weather under the most extreme conditions imaginable, and it sharpens our ability to analyze the atmospheres of these faraway worlds. But maybe the most important lesson from this beautiful, brutal world is that it serves as a stark reminder of just how fragile, how rare, and how precious a habitable planet like our Earth really is. Think about it. HD 189733b is just one planet among trillions and trillions out there. It proves that nature's ability to create extremes, both stunningly beautiful and absolutely terrifying, is far beyond anything we could ever imagine on our own. And as we keep peering deeper and deeper into the cosmos, it just leaves you wondering, what else is out there waiting for us to find it?